is measured and denoted in terms of their standards, called a unit of measurement. A unit is an internationally accepted basic reference standard against which the measurements of any physical quantity. Any physical quantity, such as length, mass, or time, is measured and denoted in terms of their standards, called a unit of measurement. A unit is an internationally accepted basic reference standard against which the measurements of any physical quantity are compared. Which is a measure of length, is a fundamental quantity. It's the same with time. The other quantities, which are expressed in terms of the fundamental quantities, are called derived quantities.
Introduction. Mechanics consists of three principal branches: statics, kinematics, and dynamic.
Vectors, scalars and vectors. Scalar quantities. The physical quantities which are completely specified by their magnitude alone are called
Parallelogram law of vector addition. This law of vector addition is applied when the two vectors act on the same point at a certain angle.
Velocity. Since displacement is a vector quantity, so the velocity acceleration. Since the velocity is a vector quantity, since the average speed is defined distance traveled by the particle in first 3 seconds at the rate of 3 meters per second equals we have x equals
Have you ever wondered why a velodrome track is curved? Or on a rainy day, while driving a car at high speed, what happens if you take a sharp turn on a flat road? You will get the answers to these questions in this module. You have earlier studied the acceleration of a body moving in a circle at uniform speed. Here, Fc, the force toward centripetal force, is mv squared by r. A simple example of centripetal force is that of a stone tied to a string and rotated in a circle in a horizontal plane. The tension T in the string provides the required centripetal force. This tension in the string is due to the pull exerted on the string by the person, which prevents the stone from flying away. Similarly, a car moving along a circular path at uniform speed also requires a centripetal force to keep it moving along the desired circular path. In this module, we will analyze the forces acting on the car during this motion.
Let's now try to understand Kepler's laws. He did a lot of good work. Now, according to Kepler's first law, all the planets revolve around the Sun in their respective elliptical orbits, and the Sun is one of the foci. Now let's move to Kepler's second law. Look at the figure carefully. The line joining the planet and the Sun sweeps out equal areas in equal intervals of time. So you see that? These two areas are equal. Fine? And then there is Kepler's third law, which is very mathematical in nature. It says, and listen carefully, the cube of the mean distance between the planet and the Sun is directly proportional to the square of its orbital period, T. We can write it down as r cube is proportional to t squared. So r cube by t squared is a constant. I'm sure you've heard of Newton. Now, Newton used the second and third laws of Kepler, and he formulated the inverse square law of gravitation. And what is that? Well, the force of gravity between the two objects is inversely proportional to the square of the distance between them. There it is. F is proportional to 1 by d squared, and that is your inverse square rule.
In this module, you will learn about different applications of elastic behavior of materials. You might have seen a crane load supply. The crane's thick metal load does not apply. This happens because the spread due by load is less than the elastic load. Thus, the cranes are designed to reduce the stress by varying the diameter of the rope as per the elastic limit of the material of the rope. Just like cranes, bridges are also designed in a way that they are not affected by the stress of the load. However, after many years of use, cracks occur in the bridges. This happens because the bridges lose their elastic strength due to the continuous stress produced by the load. Such bridges become unsafe for use. The special design of the bridges we are referring to make use of beams. The beams used in bridges play an important role in reducing the stress such that they can withstand the huge load of moving traffic and people. Let us understand how. Let us consider the case of a beam loaded at the center and supported near its ends as shown. The beam of length L, breadth B, and depth D when loaded at the center by a load W sags or bends by an amount delta given by the following formula, where Y is the Young's modulus of the material. We can see that to reduce the bending or to increase the elastic limit of the beam for a given load, we should use a material with a large Young's modulus Y. For a given material, as you can see from the formula, increasing the depth D can reduce the bending to a great extent. but on increasing the depth, the bar may bend as shown. This is called buckling. To avoid buckling, changing both the breadth and depth are made and an R-shaped beam flange is used. This section provides a large load-bearing surface and enough depth to prevent bending. This shape reduces. We know that the photoelectric effect is a phenomenon that magnetic circuit in the form of a coil with a spark gap placed which are detected by the resistor. To use the trace, the tip and the receiver, the glass